Hello students, today we will start with matrices and determinants. So what is matrices? In mathematics, a matrix or plural form is matrices is an arrangement of numbers into rows and columns. The horizontal lines in a matrix are called as rows and the vertical lines are called as columns. So what is matrix? A matrix is a set of numbers which are arranged into rows and columns. Unit is 11th. Matrices and determinants. So a matrix is a set of numbers which are arranged into rows and columns. A matrix with m rows and n columns is called as m into n matrix. When there are m rows and n columns, then the matrix is called as m into n matrix. It is commonly said that m into n matrix is of an order m into n. The order of the matrix is always given with the numbers of rows first, then numbers of the columns. Okay. First is number, m denotes the number of the rows and number of the columns, n denotes. Okay. So when you have to denote the matrix, A equals to A of ij m into n. To define m into n matrix, A matrix is A. In this case, the entries A, I, J are defined separately for all integers. That is, 1 is less than or equals to I, less than or equals to m, and same for the J and n. So we cannot denote a general 3 by 4 matrix as like this 3 by 4 matrix. A equals to A of ij, that is 3 by 4 matrix. Okay, this matrix you can denote it with A equals to A of 1 1, A of 1 row second column, A of first row third column, A of first row fourth column, A of second row first column, A of 2 2, A of 2 3. That it means 2 3 means second row third column, A of 2 4, then A of 3 1, A of 3 2, A of 3 3, and A of 3 4. So it denotes having 3 rows and 4 columns. 3 rows, 4 columns. So examples, we will take A equals to 1 2 3 is a matrix with 1 row having 1 row and 3 columns. A has the order 1 into 3. So next we will see B equals to 1 5 2 5 2 9 and 2 9 8. So this is the matrix with 3 rows and 3 columns. So this is the called as matrix. There are different types of matrices. Like one is row matrix. First we will see as row matrix. In row matrix, a matrix having only one row is called as row matrix. Only one row. So if P is an row matrix, then its order is of the form 1. If P is an row matrix, then its order is of the form 1 into n. Okay. So it will be denoted as P equals to 1, 5, 7 minus 4. This is row matrix as it has one row and 4 columns. Okay. This is called as row matrix having only one row. Okay. Then column matrix. Second is column matrix. Here you can see the column matrix like A having A, B, C, many. You can put the many rows, but only one column. Then it has 3 rows and 1 column. This is called as column matrix. Next, we will see square matrix. Third type is square matrix. Here, the number of rows in a matrix is equal to number of columns. So, example is A equals to 2, 3, here 3, 2. This is the here the matrix with 2 rows and 2 columns. This is equal in square matrix. Then 0 or null matrix. If every element in a matrix is equal to 0, then this matrix is called 0 or null matrix. Every element of the matrix is 0, then this is 0 or null matrix. Then unit or identity matrix when the a square matrix. Okay, so what is square matrix? Here we have seen the square matrix. The number of rows and number of columns are equal, in which all the diagonal elements are equal to 1 and all non-diagonal elements are equal to 0. So identity matrix or unit matrix having the diagonal elements, this is the diagonal elements are 1 and remaining non-diagonal elements are 0, then this matrix is called as unit matrix. Next is sixth type is diagonal matrix. A square matrix in which all the non-diagonal elements are equal to 0. Okay. Note that in diagonal matrix, all non-diagonal elements are equal to 0 and some or all the diagonal elements may be equal to 0. Okay. So here we will take the example of the diagonal matrix. Like here you can see this is also diagonal matrix where here the diagonal matrix may be 0 also. Okay. So this is also diagonal matrix. Triangular matrix, we will see 7 type as a triangular matrix. There are 2 types, upper triangular and lower triangular. So we'll see first is upper triangular and lower triangular matrix. So P matrix having 1, 2, 3 and 4. And here is 0. So this forms the upper triangle of the matrix. So this is the upper triangular matrix, and lower triangular matrix, here you will 1, 2, 3. This is 4 and this is 0. So this forms the lower triangle of the matrix. So this is, here you can put the values also. Okay. So here it forms the lower triangular matrix. So next, transpose of matrix. If A is a matrix of order m into n, then the transpose of the matrix A is denoted by AT or A dash. Okay, transpose of the matrix. 8 type is transpose matrix. It is denoted by AT or A dash. So is a matrix obtained by interchanging the rows and the columns of the matrix. Okay. So here you can change the row. Suppose the given matrix is A having 1, 2, 3, one row having 3 columns, order 1 into 3. Here you can transpose of the A matrix will be like this 1, 2, 3. Order will change. Okay, this is called as transpose of the matrix. Symmetric matrix. Next type is symmetric matrix. A square matrix is a symmetric matrix if two ij and here ji will be equal for all I and j. So in symmetric matrix, a matrix is given as 2, 2, 2, 2. This is given matrix, then the transpose of this matrix is also 2, 2, 2, 2. Okay. Second example of the symmetric matrix like 1, 5, 2, 5, 2, 9 and 2, 9, 8. Okay, this is 2. So the transpose of the given matrix is 1, 5, 2, 5, 2, 9 and 2, 9, 8. So the elements are equal. Hence, these two matrices are symmetric matrices. Okay. So we will see next algebra of matrices, that is equality of matrices. Two matrices are equal if they are of the same order and if the corresponding elements are also equal. So if A is Aij and Mn is the order, then these two matrices A and B matrix, A equals to B if and only if Aij equals to Bij for all I and j. So we will see algebra, that is we have to see the addition, subtraction, multiplication of the matrices. So first we will see addition of the matrices. Here example, we will start with directly with example, that is the matrix having elements as 2, 2, 2 and the second matrix having elements as 1, 2, 3, 4. So you have to add these two matrices. How you will add A plus B? So here 1 to 1 addition is there. Okay. So you have to add the elements directly. 2 plus 1, 2 plus 2, 2 plus 3 and 2 plus 4. Okay. This is 3, 4, 5 and 6. This is the result of the addition. The addition of matrices is commutative. Here you can add A plus B equals to B plus A, or addition of matrices is associative also. So you can add A plus B plus C equals to A plus B plus C. This is associative property and this is commutative property. If you add 0 to the given matrix like A plus 0 equals to 0 plus A, then you will get as A, where 0 is the null matrix of the order. So next we will see this. We have seen the subtraction of the addition of the matrices. Next is the subtraction of matrices. Second topic is subtraction of the matrices. So here if the given matrix A is given as with elements 4, 5, 1, 9, and the second matrix is 1, 2, 3, 4. So this is 3, okay? 3, 4. Then here you can subtract the matrices. So here you can subtract 4 minus 1, 5 minus 2, 1 minus 3, and this is 9 minus 4. Okay, corresponding elements you have to subtract, like 4 to this, 5 to this, 1 to this, and 9 to this. Okay, you have to subtract this element, so you will get result 4 minus 1 as 3. Okay, right? Then 5 minus 2 is 3, and here you will get minus 2, and this is 5. Okay, this is the result of the subtraction of the matrix. Next we will see scalar multiplication, how to multiply two matrices. So we will rub this. So next thing we will see scalar multiplication. Okay, scalar in scalar multiplication, if the given matrix, suppose A is the given matrix, any matrix, and K is a scalar. Okay, K is scalar, that is a real number, then Ka. You have to multiply it as Ka. The scalar multiple of A is defined as Ka. Okay, so you have to multiply the given matrix with K, that is the real number. So if the A is given as 2, 2, 2, 2, and the K value is equals to 1 by 3, then Ka, what is the value of Ka? Equals to 2 by 3, 2 by 3, 2 by 3, and here is also 2 by 3. That is, we have multiplied the given matrix with 1 by 3 real number. Okay. So this is scalar multiplication. The next is multiplication of the matrices. If two matrices A and B are such that the number of columns of A is equal to the number of rows of B, then their multiplication denoted by AB can be performed. Okay. When the number of columns of the A is equal to number of rows, okay, then multiplication can be performed. So we will see the example, like if the given matrix A is given as 1, 1, 1, 1, okay, and the B having 1, minus 1, minus 1, and 1. So we will check whether it is the mat A's columns is equals to, this is the column, is equal to number of rows of the second matrix. Okay, so we will check whether it is same, then the multiplication can be performed. So here how you will multiply. So first this row you have to multiply with this, then you have to multiply with this. Okay, so A by A multiplication B, 1 into 1 plus 1 into minus 1. Okay, then we have multiplier like this. Okay, so next you have to multiply by like this. So minus 1 So -1 into 1 plus 1 into 1, 1 into 1 plus -1 into -1, and here -1 into 1 plus 1 into 1. So you will get, this is 1, this is -1. So you will get 1 minus 1, here -1 plus 1, here 1 minus 1, and this is -1 plus 1. So you will get result as 0, 0, 0 and 0. Okay, this is A multiplication B. So next we will see properties of multiplication of matrices. A, B, C are matrices such that their multiplications are possible. 0 denotes null matrix of appropriate order and 1 denotes identity matrix of appropriate order. Then multiplication of the matrices is not commutative. A, B equals to B into A. For all matrices A and B, multiplication of matrices is associative. So associative property is A, B, C equals to A, B and C. This is associative property. Null matrix property is A plus 0, 0 plus A, or it is A. So this is, no, 0 is null matrix of appropriate order. Next is determinants. What is determinants? We will see. So what is determinants? If A is a square matrix of real numbers, then the determinant of A is certain real number assigned to the matrix A. It is denoted by, so how you will denote the determinants? So this is determinant A, okay? Or you can also denote it as determinant A. Determinant of a matrix of order 2 by 2. So how to calculate? If the given matrix is given as A11, A12, A21 and A22, this is the given determinant of matrix 2 by 2, then the determinant of A, how you will calculate, is A11, A12, A21 and A22 is equals to, we have to multiply, cross multiplication, okay? A11, A22 minus A12, A21 and A12. This is the determinant of A. So example, we will take the example as A1, 2, 3, 4. Then its determinant is 1 into 4 minus 3 into 2. Then you will calculate it as, this is the determinant of A. Okay. Matrix 3 by 3. So example 1, 5, 2, 5, 2, 9 and 2, 9, 8. So how will you calculate the determinant? So this is matrix 3 by 3, A matrix. So you have to calculate, how you will calculate. So this is the first, then you have to cross multiply. 2 into 8, that is 60, minus 9 into 9 is 81. Okay, next is 5. Okay, this 5 minus 5 So you have to cross multiply 5 into 8. Okay, 5 into 8 is 40 minus this 9 and this 2 is 18, then plus this 2. So 9 into 5 is 45 minus 2 into 2 is 4. Okay, this is how this is minus 65. This is 5 into 22. So this is minus 112, and this is 41 into 2 is 82. So you will get minus 93 as the result of the matrix determinant A. So singular matrix, what is singular matrix? A square matrix A is said to be singular matrix if its determinant is equal to 0. If the matrix determinant is 0, then this is called as singular matrix. Otherwise, it is called as non-singular matrix. So here A equals to 2, 2, 2, 2. So when you will multiply the 2 into 2 minus 2 into 2, then you will get it as 0. This is the singular matrix. So next is, we have seen the singular matrix. Next is inverse of the matrix. If the given matrix is given is an square matrix, then the minor of the I and J elements, Aij is the determinant of the submatrix obtained by deleting ith row and jth column from A. It is denoted by Mij. So inverse of the matrix, how you will, if the two square matrix A and B are such that AB equals to BA equals to I, where I denotes identity matrix of the same order, then B is known as inverse of A, and it is denoted by A inverse. Okay, this is the inverse matrix. If the B is inverse of A, then A is inverse of B, that is B equals to A inverse. Then A equals to B minus 1. This is inverse of the matrix. Next, we will see cofactors of an element. Cofactors of the elements. When the given matrix is square matrix, then cofactor matrix of A is a matrix C, I, J, N into N, in which I, J element C, I, J is the cofactor of element I, J of A. So, next is, this is the cofactor of the, it is denoted by C, cofactor of the matrix. Next is adjoint of a matrix. Adjoint of a matrix A is the transpose of the matrix of cofactors of A. This is denoted by adjoint of A. So I will share this things, what is adjoint factors and all the things about the matrices and determinants. If you have any doubt or query, please message me or call me. Thank you everyone.